Welcome back to good day and welcome back to Everything Mathematics. And today we're going to continue our series on surds, of course. And today we will be looking at Rule 3. And last 2 days on Wednesday, we would have looked at Rule 1. Yesterday, we looked at Rule 2. Today, we're going to look at Rule 3, and it's a rule that I pretty much alluded to yesterday. And Rule 3 basically introduces us to the whole concept of rationalizing. So today we're going to learn basically the gist of rationalizing. So rule 3 algebraically states this. If we have b over, let's say, root a, as I said yesterday, somewhat for whatever reason, or at least when dealing with surds, we do not or cannot have a square root at the bottom. So what do we do to get rid of the square root? We basically multiply by whatever it is that is under the denominator. So there we'll be multiplying in this case by root a, and you're multiplying by root a. And when you do this, here what happens? Of course, you simplify from there. So at the top, you end up with b root a, and at the bottom, you would end up with just a. The square root disappears. And again, this could be justified. This is very easy to justify. So one of the things you could see as root a multiplied by root a, think of this. Think of root a times root a. When you do this, in essence, you will have root a all squared. And as we go back to the subject of the formula now, back to algebra, we know that to get rid of a square root, you square. So the square basically gets rid of the square root, thus leaving the a all alone. So basically that's how you do it. Of course, you could have more intricate cases where you have a constant in front here, but maybe we will deal with those in another video. I think that may be down to rule 4 or 5, somewhere down there. So yes, this is the essence of rule 3. So if you have a rational b and the denominator is written as a square root or under square root, you basically just multiply that by whatever it is that the square is square rooted, and it gets rid of it. And of course, whatever you do at the bottom, you do at the top to maintain equilibrium, I should say, or balance in that equation, right? So let's see if we could do a few examples. So imagine we have, for instance, let's say we have 5 over root 7. And again, as I said, this rule is very easy. I mean, once you understand it, it's a very simple concept. So 5 over root 7, again, we try to rationalize that. So we have 5 over root 7, and we're multiplying that by root 7 at the top and root 7 at the bottom. Matter of fact, let me even write it as a fraction. I don't want to write it as a fraction because it's not really a fraction. But it's just, in essence, it's saying whatever I'm multiplying the bottom with, you multiply the top with. That is what's really happening here. And when you do that, you will end up with, at the top, you end up with 5 root 7, and at the bottom, you will simply end up with 7. Good? Another way you could see this, and I mean, another way to think of it is that whenever you multiply a number by itself, you will always find a perfect square. Remember when we look at the first video, for example, if you want to find a perfect square, just you square the natural numbers. Each natural number that you square, you find a perfect square. So 1 times 1, that will give us 1. So 1 is a perfect square. 2 squared will give us 4. 3 will give us 9. 4 will give us 16. 5 will give us 25. So all these here are perfect square because the square root will give us back a whole number, a round number. Good? And that's one of the things that we have to be able to get from this. So when we do that, that is what would happen. Good? So in essence, once we square a perfect square, once we square it a perfect square, we end up with a number. So the reverse is also true. If we multiply 2 single numbers, we will get the perfect square, and the square root of the perfect square is the number itself. So that's one way to maybe think of this if we cannot see it like that. Let's try this one. What if we have root 3 over, let's say, root 5? This should be an interesting one. So root 3 over root 5, and again, I want to rationalize this. So remember, this is the same as saying root 3 over root 5 multiply by root 5. I'm multiplying by root 5 because it's the denominator. I am de-rationalizing, if I should put it like that, because I want it to not be a square root. When I do that, at the top, notice I will have root 3 times root 5. And at the bottom, I will just end up with 5. And at the top, since these two numbers are not perfect square, we could just end up with 1 root 15 over 5. This is almost like the reverse of rule 1. Remember in rule 1, we try to separate them. But here, since they're already separated and we cannot find a square root, well, they don't exist really, it will be a decimal, then we could just rejoin them in essence. So we have root 15 over 5. And yes, that's basically the rule. So let's see if we could just do a couple more and then maybe call it quits. So imagine you have something like what? What if we have 8 over, let's say, root 6? And again, this is as simple as it comes. The following rules might be a little more intricate, but this is as simple as it comes. So let's do maybe 2 and wrap it up for today. Because I mean, the more I do wouldn't change the fact of the simplicity of it. How the yellow looks. Yeah, you could see yellow, right? Let me put a darker color just in case. Right. And here we could have something like what? Root, let's try root 3 over root 6. Oh no, I root 6 in that other one. I don't want it to do that for a reason, ever. Let me change it to root. Let me leave it so, man, because this one I want something to come out from this. The first one, nothing may not come out from this. So for this first one here, we will have, of course, 8 over root 6, and we are multiplying that by root 6 at the bottom, root 6 at the top. So this will leave us with an answer of 8 root 6 all divided by 6. That's it. That's the answer here. On the other side, let us notice something interesting taking place here. So at the other side, we will have, basically we have root 3, and at the bottom, we will have root 6, and we're multiplying by root 6. You always multiply by the denominator, right? So in case you're wondering how do you know which one to multiply, you always multiply by the denominator. So at the bottom here now, we would end up with just this 6, because the roots cancel off and it leaves you with whatever is inside it. And at the top now, we will end up with root 18. But now we have to see that root 18 can be further simplified, because root 18 is the same. Let me do some work here. Root 18 is actually the same as 9 times 2, right? And again, this is back to rule 1, which we did 2 days ago. But in essence, at the ending of the day, we will end up with 3 root 2 all over 6, which in turn will leave us with root 2 over 2. The 3 could go into itself once, and the 3 could go into 6 twice. So we end up with root 2 over 2 as our final answer. So yeah, I did this one just as I said, I expected something to come out from it, so I did it like that. And I think this is as complicated as it could come. So you have to be versed and you have to be vigilant to see that if you get a fraction that could end up being rationalized at the top, not rationalized, but simplified, you do that. Don't just leave it like that. So don't leave the root 3 times the root 6 and say, okay, that's it. The bottom is de-rationalized, or the bottom has no longer has a square root. In as much as, yes, that was your aim, simplifying is also part of the process. So yeah, I think we're going to stop it there for today. Next week, we're going to continue with the other rules. I think there are 6 rules in all. And then after, we're going to see if we could do some practice questions incorporating the various rules. So until then, as always, feel free to like, share, and subscribe if you haven't as yet. And you do take care. Have a blessed weekend.